Until recently, when we looked at humanoid robots in short, well-edited videos, they seemed pretty smart, didn't they? They walked, balanced objects, and sometimes did parkour, but once the environment changed, everything fell apart. An unexpected step, an object out of place, a slightly more abstract instruction, and the illusion of intelligence simply disappeared. But with the advent of artificial intelligence, something changed. For the first time, we didn't just see better robots, we're now seeing robots that think, learn, remember, adapt, and scale all of that. And when these abilities come together, the result is not just impressive, but in a way, uncomfortable, and at the same time, exciting. I know. For today's episode, I chose 7 of the most promising and dangerous humanoid robots for 2026. Stay tuned. I'll show you everything after the intro. Hello, impressed viewers. I'm Carlos Alves, and you're watching Incredible Reality. Let's get to the video. Yeah, my friends, the machines that learn by themselves, understand intentions, remember people, and already work in factories, homes, and extreme environments, they're among us. Now, in 2026, what has changed is not just the body, but the brain of these machines. 2026 began with robots that learn from humans, plan independently, adapt in real time, and work for hours without breaks. Some even work under rain, dust, and extreme heat. Others learn new skills in just a few hours. And some were designed to live inside our homes. These robots are not coming. They have already arrived. And the impact of this could be much greater and faster than any previous technological revolution. The fact is, they are promising, there's no denying that because they work, but they're also dangerous because they change the rules that sustain our world, the human world. If you watch this whole video here without skipping around like a crazy animal or speeding it up, you'll be able to connect all the dots and you'll never see humanoid robots the same way you did today. I guarantee you that. Strength, speed, and balance stand out, but ultimately they don't matter. If the machine still depends on rigid commands, the real breakthrough happens when the robot understands intentions, remembers people, and decides on its own what to do in unpredictable environments. And this is exactly where the first humanoid on our list comes in, because it doesn't start with the body, it starts precisely with the brain. A Chinese company has launched a cognitive operating system for real-world robots, which could redefine humanoid robotics. It's not a new robot, but software for existing robots. It's called Lightnecks Cosa, a system that transforms robots into agents that both obey and understand their actions. For a long time, robots carried out orders through commands, but now they are starting to understand objectives. Lightnecks Dynamics introduced the real breakthrough that was missing: the digital brain, which allows a robot to interpret intentions. When told, get 2 water bottles and find the guest. The system doesn't follow a fixed sequence. It understands the goal, breaks down the problem, navigates the environment, avoids obstacles, and adjusts in real time. Cosa creates a semantic worldview, recognizing people, recalling interactions, understanding spaces, and acting proactively. It's not just computer vision, it's memory, it's context, it's decision-making. This becomes clear in Lightnecks OLI, the company's full-sized humanoid, which is already being implemented in the real world. In demos, Ollie climbs stairs while carrying objects, moves fluidly, and adapts to unexpected changes without stopping or restarting. This happens because the system separates high-level intelligence and motor control into cooperative layers. A large brain, which is responsible for reasoning and planning, and a small brain focused on balance, movement, and physical precision. Thinking and acting are finally aligned, resulting in a subtle change. Robots stop just blindly obeying human commands and start to understand what is being asked of them. And when a machine understands human intentions, the next step is inevitably to give it a body capable of responding accordingly. If Lightnecks proves a robot can think, Unitree H2 proves it can act physically. For years, watching a humanoid robot move was impressive. Now, it's the way it moves that's becoming unsettling. Unitree Robotics released a new training video of its humanoid H2, showing something that until recently seemed unique to humans: precise strikes, flying kicks, backflips, and very strong impacts. Strong enough to knock down sandbags and even human beings. The H2 is Unitree's most advanced humanoid robot, nearly 6 feet tall and about 70 kilograms, showing clear evolution over the previous model. The H1, known for its speed at public events in China, has already broken several records. Now, the focus is on total body control during dynamic, aggressive movements. A powerful blend of hardware and software drives this impressive performance. The H2 features 31 degrees of freedom and actuators delivering up to 360 Nm of torque, matching the strength of human athletes in explosive movements. Advanced motion control algorithms coordinate these actuators, enabling the robot to maintain balance, posture, and precision during rapid, complex actions. This all occurs when he's throwing kicks or punch sequences. It's clearly dangerous. Another key advancement is with the arms and hands. Unlike previous models, the arms of H2 now have 7 degrees of freedom, making their articulation closer to human anatomy. This shows a very clear shift in priorities. The robot is now more than a machine that walks. It's a platform for precise manipulation and real tasks, something essential for factories, logistics, and eventually homes. And we also know that in the military world, this will be there. Well, let's leave that for another time, for another video. The images also reveal something equally relevant: the growing use of teleoperation. Although full autonomy is still the ultimate goal of these companies, Unitree has invested in systems that let human operators remotely control this robot with wearable devices and mixed reality headsets. This approach allows human judgment and artificial intelligence to work together, speeding up deployment in the real world. While autonomous systems are still maturing and becoming safer over time, or so the companies say, right? The H2 proves something essential to us. If robots are to function in the real world, they need bodies that can handle real forces. And here's an irony: a powerful body only truly becomes dangerous when it starts learning on its own. And maybe that's already happening. At least that's what the American company Onex has claimed. Teaching robots used to be costly, slow, and artificial. Onex challenged that idea. The humanoid Neo now learns on its own just by watching videos, exactly like humans do. The company recently launched the Onex World Model, a video-based AI system enabling the robot to learn behaviors by watching people and interacting with the world. And no, these aren't robotic examples. Okay, it's not a video of a robot watching another robot. They're regular videos of humans at internet scale. The robot analyzes the scene, visually predicts future actions, and converts that prediction into real movements using an inverse dynamics model. It imagines what will happen next and then starts doing it. In demos, Neo makes lunchboxes, opens sliding doors, lifts toilet lids, irons and combs hair, often with objects it had never seen before. In other words, it was the time it spent watching the videos that taught it how to do it. Then, it just needed to remember what it saw. This robot doesn't just perform tasks, it learns constantly. Each interaction adds data, creating a cycle where action leads to more learning. This addresses a major bottleneck in humanoid robotics, transferring digital intelligence into reliable physical actions. When robots start learning like us human beings, the question changes a bit. It's no longer whether they will evolve, but at what speed they'll do it. But learning alone isn't enough. It's essential to learn quickly. With that in mind, PD Robotics launched a new robot ready for action. Let's take a look at that. Adan U Ultra doesn't require lengthy calibration or manual programming. It already comes with a large VLA model, specifically trained for its physical structure. This enables the robot to understand commands, interpret its environment, and act autonomously without manual adjustments. The result is that the robot performs complex tasks almost immediately after being turned on. The secret lies in the deep integration between the hardware and artificial intelligence. The system includes over 10,000 real-world data samples gathered from robots in physical environments. And as a result, with just a few additional data points, new skills can be learned and deployed in a matter of hours. The hardware keeps up with this ambition. The quasi-direct drive joints known as quasi-direct drive provide high torque with smooth response and precise control, reducing delays and allowing for almost natural movements. Here, Borix makes his philosophy very clear. Progress doesn't come only from bigger models, but from the close fusion between the body and artificial intelligence. Atom Ultra doesn't need to be prepared for each task. He comes ready to learn, and when robots learn quickly, the next step is to put them into our daily routine. That's exactly what the American company Figure AI is focused on. They chose to tackle the most challenging environment, the human home. The Figure 03 wasn't designed for laboratories or clean factories. It was made to live with people in unpredictable environments, full of objects, children, animals, and all the mess that we have. This third-generation humanoid is a total redesign of the company's hardware, software, and manufacturing. The guy's goal is ambitious: to make robots truly versatile, capable of learning directly from people and performing tasks similar to ours, human tasks. All of this is happening globally, led by Helix, the company's proprietary AI. Unlike fixed routine systems, Helix uses vision, language, and action together in real time for ongoing physical reasoning. The robot now has a redesigned sensor suite with faster cameras, lower latency, and a wider field of view. The robot now sees better and understands its environment while moving. Its hands, second only to the brain in importance, have also evolved quickly. Each one now has its own palm cameras and tactile sensors developed in-house. This came after Figure concluded that existing solutions couldn't withstand real-world use. This hand is so sensitive that the robot detects forces of just a few grams, anticipating slips before they occur. This lets it handle fragile, deformable, or irregular objects with control that recently seemed like science fiction. But perhaps the most revealing aspect of Figure 03 is its focus on domestic use. It is lighter, smaller, and, in addition, covered with soft fabrics and foams of multiple densities. To reduce the risk of impact, the fabrics are washable, replaceable, and even customizable. The robot was completely designed to live alongside us, human beings. These guys don't just want the robot to operate near us. They want it to truly coexist with us. The battery sets new safety standards with multi-layer protection, international certification, and fully wireless charging. Figure 03 walks to the base, positions itself, and recharges independently during the day. And while it recharges its battery, it uploads terabytes of data via mmWave for continuous cloud learning. And all of this is already designed for mass production. Unlike previous generations, Figure 03 was designed from the start to be manufactured on a large scale. The company built a supply chain and launched Botiu, its industrial facility, initially able to produce 12,000 robots annually. Their clear goal is to deploy hundreds of thousands of humanoid robots, impacting far more than just homes. By tackling the challenges of the chaotic home environment, Figure creates an ideal robot for factories, logistics centers, services, and commercial operations. Faster actuators, higher torque density, precise handling, and almost continuous operation make Figure 03 a platform designed for a world at scale. And even though it may sound simple, what I'm going to say, despite all this technology, is there's something missing from Figure 03. It can't work in the rain, at least for now, right? The technology to resist water exists and is already used in China. Let's take a look. The DX-02 overcomes a key challenge in humanoid robotics: environment limitations. It's the first industrial humanoid robot with a full-body IP66 rating. Completely protected against water and dust, this means something simple but revolutionary. It can operate outdoors, in the rain, in dusty environments, and under real weather conditions. Previously, this has always been a weakness in humanoid robotics. While most robots that mimic our anatomy need controlled environments, the Chinese DX-02 was designed to move seamlessly between dry factories, outdoor yards, rainy areas, and even refrigerated storage facilities. It operates continuously from -20 to 55 degrees. When traditional robots fail and resilience alone isn't enough, the DR-02 was built to operate and move like a human in human spaces. With an ergonomic design about 1.75 meters high, it fits existing industry tools, corridors, stairs, and facilities. It walks steadily, climbs stairs, handles steep inclines, and stays balanced even when carrying a load. This means the robot can work in logistics, material transport, inspections, emergency response, and ongoing industrial operations. Even in high-risk areas for humans, this physical robustness relies on a high-performance architecture. The DR-02 has a multi-sensory perception system and 275 tera operations per second of computing power, letting it interpret its environment in real time. It adjusts movements, avoids obstacles, and reacts precisely to unexpected situations. Another key aspect is its maintenance philosophy. Unlike traditional robots that need long downtimes, DR-02's modular design allows quick disassembly. Arms, forearms, and legs can be removed and replaced quickly, drastically reducing downtime and operating costs. This makes the robot an evolving platform that can be upgraded over time without being discarded. Here, the humanoid stops being fragile, it truly becomes industrial, and when the robots think, learn, and withstand the environment. One small thing is needed to transform everything and boost production. Elon Musk has promised to do it. Let's take a look. Tesla Optimus Generation 3 is in the final stage of development and pilot production, making it clear that this is no longer an experiment, but a product being prepared for the real world. The third generation of Optimus was designed with a very specific goal: to perform human tasks with a fluidity close to that of a real person, an ordinary person, both in industrial environments and in domestic settings. And that starts with the hands. Robot. Now it features hyper-dexterous hands, which are capable of performing extremely delicate movements, such as handling fragile objects or carrying out tasks that require millimetric precision. The real difference of Optimus is not just in its hardware. It is trained using the same brain that drives Tesla cars. The full self-driving computer runs the neural networks, enabling the robot to learn from watching humans in videos. This is directly reflected in physical performance. Tesla claims that Gen 3 moves up to 3 times faster than the previous Gen 3 generation, with twice the precision. Recent demonstrations showed the robot running, balancing, moving forward, and doing martial arts-inspired moves. Something unthinkable for commercial humanoid robots until recently. Optimus Gen 3 is now closer to human size physically, around 1.77 meters tall, just over 70 kilograms with up to 10 hours of battery life. This makes it viable for full shifts in factories or long domestic routines. And that's exactly where Tesla is testing this robot before any public sale. The first units are being deployed inside the company's own factories, performing repetitive tasks on the assembly line. It's a clear strategy to prove economic efficiency. Before scaling up, Elon Musk has already made his ambition clear. The target price for Optimus, when mass production begins, should be between $20,000 and $30,000. That's the cost of an economy car. To support this, Tesla will launch a dedicated humanoid robot production line in 2026. Musk says that in the future, the world will be a place where millions of robots will cook, clean, work, and take care of basic tasks in our daily lives. After everything we've seen in this episode, my friends, it's hard to ignore what's happening in the world. These robots are not concepts anymore. They're not just lab prototypes. They're not ideas for 20 or 30 years from now. They already walk, they already learn, they already make decisions, they already work, and in some cases, they already replace some humans. We've witnessed more than technological advancement. It's a quiet shift in how humans and machines relate. For the first time in history, humanoid robots are not just being trained to perform certain tasks, but to understand intentions, memorizing people, learning independently, and acting autonomously in the physical world. This raises a question that's somewhat uncomfortable when a machine learns by observing us, human beings. When it works without rest, when it costs less than an economy car, and when it can operate in factories, homes, hospitals, and also on the streets. What still makes human labor indispensable? Maybe the greatest risk of these humanoids isn't their strength or speed, and much less their intelligence. Maybe the real risk is how naturally they're entering our spaces. While we're still debating whether this is good or bad, because history shows that technology doesn't wait for consensus, it moves forward. It comes quickly, and before we know it, the future is already routine. I'd like your thoughts. Do these robots symbolize freedom, progress, and efficiency? Or are we witnessing the beginning of a silent, irreversible replacement that's just too comfortable for many of us to question? Share your thoughts in the comments. This discussion is about our role as humans in the world we're building, not just robots and technology. It seems that for the machines, I like technology, but things are evolving quickly and we need to adapt, both ourselves and the governments and these companies. Thanks for watching this special, amazing reality episode. Click a suggestion on your screen and I'll see you there. Bye. But before that, remember, if you're suffering from baldness or know someone with this problem, you already know. You can use the pinned comment or the description. The manual will help you or anyone you know who needs it. Just share it. Thanks now, really. Bye. See you in the next one, okay?